Now, as I said earlier, that we are going to continue looking at this. Now, let's take an example. We have got the integral of x e x dot dx, that we should be able to integrate this. So normally, from this particular point, I can be able to actually label them like this. This one can be you must make a quick check. It can be fx, and this other one can be g g prime x. So let me just swap here. Here it must be prime, and here it must be prime, and here it must not be prime, and here it must not be prime, so that this one becomes gx, the one which you can continue integrating. And then in this case, looking at the formula, so you actually say, what about fx? So fx is equal to this one, is equal to this one. So in this case, I will have fx as the x, and then gx is equal to this one. But here I need to find what is my gx. Now my gx there is equal to ex, and the yeah, so it's my ex. So here I should now take integral. Now the integral, now I need to look at the, now you can see that now fx is equal to x, and the gx is equal to ex. So we need to find out now what is the f prime x. So f prime x, the answer is equal to 1. What about the g prime x? G prime x, the answer is ex, so it is not changing. So in the end, you take these values and then take them into the equation, and this particular equation, you take this and then you actually say this is equal to g prime x. It is something that is here, g prime x. It is something that is there, which is equal to it is now going to be equal to ex, okay, multiplied by the value that we have there, which is equal to, now let's look at this was the f prime, sorry, it was f prime. So because it was g prime, so it was g prime, which we must be able to look at. So at the end, we have got now half x to the power 2 dx, x to the power 2 dx. And then having done that, we can now be able to do the simplification of the results, and be able to determine what could be the values of the statement. Now I can rewrite it better so that we can be able to complete the calculations. So in this case, I have got the integral of ex multiplied by x dx, and is equal to ex multiplied by half x squared, okay, and then minus integral of ex multiplied by half x squared dx, where in this case this is equal to f of x, and this is equal to g prime x, and this is equal to fx, and this is equal to gx, and this is equal to f prime x, and this is equal to gx. So after that, you can be able now to simplify, because you can easily get the integral of that. So that's the way. So what I want you to look at is when looking at integration, we normally can be able to look at it from a different angle. So you can actually check this one and see whether you can get it, or you can get this one, integral of 3 x exponential of 4x dx, and you should be able to look at even the integral of 1 minus plus x squared bracket e negative x dx. I want you to look at these ones just to use the equation. So the equation, it must be integral of fx g prime x, okay, dx is equal to fx gx, okay, minus integral of f prime x gx dx. So this is actually the equation. So you must be able to use this equation to translate your part. Take note that if at this point we have got this one, we have got at this point we have got this one, okay, we have got this one. So if it is g prime x, if this g prime x is equal to any value here, it means that this is the marginal cost of that particular value. So for you to get like the cost, or for you to get the value which is raw, then you must be able to integrate g prime x so that you get what is c. So that's the most important part. It's actually important to actually have things in that sort, and that's the most critical process, which is very important. And having done that, I want us to actually reconsider the other processes, and this time around we are going to discuss integration by substitution. We're going to discuss integration by substitution so that we can actually understand things from that particular angle before we go into the application tutorial. So that is going to be the next section